Today's video is going to be over expressions versus equations. This week we've been talking about what an expression is. An expression is when you have an unknown and then an operation with a known value, kind of like a plus 7. We don't know what the a stands for. It's our unknown. We don't know the value of it, but we do know that we're adding 7 to it. Now we're going to switch over to what an equation is. Our equal sign is used in a variety of instances. It's used in a math expression where you are actually going to solve whatever the problem tells you to do, whether it's 2 plus 8 equals, and you have it on the other side. So the equal sign actually tells you that the value on the right and the value on the left are equal in value. So we're going to look at an expression, is what we talked about the other day, and an equation. In our video about expressions, we said that an algebraic expression, and we're talking about algebra for both of these, an algebraic expression is a mathematical phrase involving variables, numbers, and operations. So an example of that could be, like I just said, a plus 7. We do not have an equal sign in an expression, so there's no equal sign. An equation is a number sentence that uses an equal sign to show that the two expressions have the same value. So we're actually going to have an expression on the right and an expression on the left, and they're going to be joined by an equal sign. So your expressions are the pieces of the equation, and then the equation throws in the equal sign. So an example we could use for an equation would be a plus 7, which maybe we're talking about how many apples are in a basket. If we added 7 to that basket, now we want to know the total of the basket. So this expression is going to be equal to this expression when I get done with whatever operation it tells me to do. So an equation has an equal sign, an expression does not have an equal sign. So when you're thinking about expressions versus equations, they're not two different things. Expressions are put together to create equations with the equal sign between them. So it's kind of like you have an expression, an equal sign, and another expression, and all of that is an equation. And it's all because of that equal sign. Equation has the same beginning as equal. We're going to practice using equations with something called an input and output box. On your student side, I want you to draw some of these input-output boxes. It's kind of like a little machine. When you think at a factory, the factory and an assembly line, it starts as something, and by the time it goes through all its processes, it comes out as something else. So if I start with 16 and it goes into the machine, I don't know what happens in the machine, but I know that it comes out 20. I can think about what in the world this unknown equals. So I can call this n because I don't know what that number is. So 16 something n, and that results in equals 20. So how in the world are we going to figure out what operation to use? Well, if I were to add another number, I could possibly get 20. If I were to multiply 16 by a number, I would never get 20. I would not get 20, I'm sorry. If I were to say 16 minus a number, I wouldn't get 20. and 16 divided by a number is not going to get 20. My thinking patterns don't work that way, so the only thing I could do is add a number. Okay? To solve this equation, I want to try to get all the numbers away from this side and give it to where the unknown is going to be by itself. So here I was adding 16. I'm going to subtract 16, and it's going to get rid of it over here, so that all I'm left with is an n on that side. Whatever I did to this side of the equation, because equations need to be equal, I have to do to this side. So I'm going to subtract 16 over here. And when I say 20 minus 16, I get 4. So n equals 4 in this equation. I'm going to put 4 into the box. And it's going to come out 16. So what would n represent? Go ahead and pause the video and see if you can figure out what you think n is going to represent. Okay, so we have 4. We know our unknown is n, and we know that it's going to equal 16. Alright, let's think. 4 minus a number, there's no way it's going to be 16, so subtraction is out. 4 plus a number could possibly result in addition, so maybe. 4 divided by a number, there's no way it's going to equal 16. And 4 times a number, maybe could equal 16. So we're down to multiplication or addition. 4 plus what would equal 16? Well, I can go ahead and do this with an addition sentence and see what happens here. So I can try to figure out what n is. I added 4 on this side. So now to get n by itself, I'm going to subtract 4. I'm just doing the opposite. So now n's the only thing left over there. Whatever I did to this side, I have to do that side. So minus 4. So 16 minus 4 equals 12. So 4 plus 12 does equal 16. So that's with addition. Let's try it with with multiplication, because we said it was a maybe. 4n equals 16. Okay? 4 times a number is going to equal 16. Well, here I multiplied, so I'm going to divide by 4. Remember we talked about fractions? Fractions are division problems. So 4 divided by 4 is going to just leave n on this side, and 16 divided by 4 is going to equal 4. So if I say 4 times 4, it does equal 16. So this had 2 possible solutions to the problem. Neither one of them is more right than the other. It's just, can you use your reasoning skills to figure out which operation to use first of all, and second of all, can you successfully solve the equation?